Hello, this is One Person Studio here. So this is episode 15 of my series Encoding Game where I solve easy algorithmic puzzles, and we're gonna start with this one: encryption, decryption of Enigma machine. Okay, so I know how to use strings, encoding, cryptography, and string manipulation. So if I click one of them, for example strings, it'll tell you what it does. So a string is a data type used in programming, such as an integer and floating point unit, but it's used to represent text rather than numbers. It is comprised of a set of characters that can also contain space and numbers. So it gives an example. For example, the word parcel and the phrase "I love coding game" are both strings. Even 1, 2, 3, 4, 5 could be considered as a string. So that's what it does. So if specified correctly, um, typically, programmers must enclose strings in quotation marks for the data to recognize as a string, and not a number or variable name. So, okay, that's what a string does. So if I click on encoding, what it does. So in communications and information processing, encoding is a system of rules to convert information such as a letter, word, sound, image, or a gesture into another form of representation, sometimes shortened or secret, for communication through a channel or storage in a medium. Okay. Um, the process of encoding converts information from a source into symbols for communication or storage. So decoding is the opposite of encoding. So decoding is the reverse process, converting code symbols back into a form that the recipient understands. So to give you an example, so in a Caesar cipher, also known as Caesar's code, is one of the simplest and most widely known encryption techniques. It is a type of substitution cipher in which each letter in the plain text is replaced by an X shifted in the alphabet. So just give an example right here. So cipher with a shifter X3, so it starts with B, then goes to D, A goes to D, C goes to F. It just moves 3 to the right. Okay, so if we click on cryptography, it tells us what it does. So cryptography or cryptology is the practice and study of techniques for secure communication in the presence of third parties called adversaries. So more generally, cryptography is about constructing and analyzing protocols that prevent third parties or the public from reading private messages. So that's what it does. And I gave you examples of different type of data right here. Yeah, so, and it also gives example like ATM cards, computer passwords. So, okay, let's go back. Okay, let's focus on the puzzle. Alright, so this is the goal. So during World War II, the Germans were using an encryption code called Enigma, which was basically an encryption machine that encrypted messages for transmissions. So the Enigma code went many years unbroken, and so basically here's how the basic machine works. Okay, so the first Caesar shift is applied using an incriminating number. So if string is triple A and the starting number is 4, then the output will be EFG. Okay, so it gives an example. So EF, so A plus 4 is E, and then A plus 4 plus 1 is F, and A plus 4 plus 1 equals G. Okay, now map EFG the first rotor, such as pretty much the alphabet, and you just plus it by 1. Okay. Or is it plus by oh, because 1, 2, 3, 4, 5, 6, 7, 8. Okay, just plus by 1. Okay, got it. So EFG becomes JLC. Then it is passed through 2 more rotors to get the dividing value. If the second rotor is this, we apply the substitution step again. So, okay. So, alright. So this is the third example. So JLC becomes BHD. If the third rotor is this, then the final substitution is okay. Right. Okay. So BHD becomes QF, and the final output is sent via radio transmitter. Okay. So it's quite difficult, this one. Okay, let's solve it though. I'm gonna change up the language. I'm gonna try JavaScript. I haven't used JavaScript for a while, so let's use that. Okay. Let's do the input. Okay. So the first line is this. It's either encoding or decoding, and the second line is the start and shift. Starting shift n, and the next lines are basically the for loop. So let's do it here. Yeah, for loop for the 3 rotors. That's what they are. And this one is basically I think it's this one. It's basically this. It prints out either to encode or decode. Okay, right. That's all good. But let's try and do my own methods. Alright. I think I got a plan. So this is the constraint. So if 0 is less than or equal to n, and n is less than 26, the message consists only of uppercase letters. Okay. And then if 1 less than or equal message length less than 50, and then this is the example right here, and this is the output. Alright, let's do this. Well, we're gonna make 3 consts. I think they already did it for us, but I want to make my own. I want to do const op, short for operations, and n, because it's right here. Because n is the start and shift. So we want to do that, and we want to read line plus read line again. So that's done. Okay, we don't need this. The second one is the rotor. We want to do that. 3 rotors. And what I want to do is I want to make 3 arrays. So array 3, and then dot map. How do you do things like that? And then I want to use this. And then I want to read line, and I want to split it. I mean, it's expected. Let me write this again. I'll write this again. It's good for memory. Alright, so const rotor is equal to array 3 dot map, and I want to read line. I want to split it. I want to do I've got the extra. There you go. So this is what the map does. So it calls a define callback function on each element of an array, and it returns an array that contains the results. And readline is basically it reads a line from input, and it splits a string into substrings using the specified separator, and it returns them as array. That's basically what it does. Alright, so that's the, oh no, rotor. Alright, so that's done. And the last one is the message. So const. It's basically that, but I want to split it. Okay, we can get rid of that. Alright, so that's the three consts. And also, I want to make I want to make another three consts. So so one of them will be like ASCII, one of them is to toIndex, and one of them is to character. Okay, let's start with the first one. Let's start with ASCII. So ASCII equals to A, and we want to use A dot char code at, and then we will start with 0. Then the second one is toIndex, and we will start with C. And then what we want to do is use this, and then we want to use ASCII, ASCII C, and then we want to take away that from ASCII capital A, and we want to use this. Oh no, my bad. Like that. And lastly, we want to use toChar equals C, and then we want to use a string dot from char code, and we want to use C plus ASCII, and then use the capital A for that. Okay, alright. So that's all done. We're gonna use the let method for encoding. So let's do encode message map, and what I want to do is I want to use the C and I, and I want to use this. It says right here, gives an example. And I want to use toIndex, and I want to use a string dot from char code, and we want to use ASCII art. So ASCII C, and then we want plus N plus I. So if that happens, and use that. Okay. Oh, there's a squeaky line there. Okay, what's wrong? Oh, forgot. Sometimes it tells you what happened. Sometimes it doesn't. So in this case, it was right. Okay. Let's use the rotor. It's this one. We want to use a for each method. So we want to use R, and we want to encode that. So encode equals encode dot map cc, not cc, sorry, just one c, sorry, and we want to use it again to index. We want to use R, and then use array C. And then we want to use another const. So we want to use the first one. It will be, I'm going to call it rotor step equal to I, and then we want to use C. This again to character, and use rotor I dot index of, and we're going to use C. So index of it returns the index of the first occurrence of a value in an array, or -1 if it is not present. That's what it does. Okay. Right. And the second one is for decoding. So const decode equal message map, and we're going to use this for the rotor step. So rotor step, we're going to use number 2. And then we're going to use a map rotor step 1, and we're going to use that to map rotor step 0. No, actually, yeah, that's right. And then we want to use that for map, and we want to do a similar method to this one. C I, and we want to use const IDX equals to index C, and we want to minus that with n, minus that with I. So instead of plus I, we minus I, because we're doing basically this is this is the opposite of encoding. So what we're doing here, and use this for 26, and then we want to return that to index. So toChar IDX is greater than 0. Use a question mark, and then IDX 26 plus IDX. Right, and then we're going to use the toConst just to print out. So we don't need this. So const decChars equals to a dot map to characters, join 2 empty strings. That's done. And now we're going to print out. So console log op. So this is what console log does. It prints out a steady output with a new line. So multiple arguments can be passed, with the first used as the primary message, and all additional used as substitution values similar to print. And it gives an example right here. So operations equals decode, and we use a question mark, and then we use stick characters, decode, and we use a colon, and we're going to do it again, stick characters, and then we're going to use that to encode, and that should be it. I think, yeah. Let's try it out. No, what's wrong with 15? Reference error. Oh, okay. 18. What's wrong with 18? It should be. Rotor dot for each is not a function. Oh, it's because I forgot a capital E. There you go. Just do it again. Okay, well that's it. This is a really long episode, so if you managed to watch the whole video, I appreciate that. And I'll see you in the next one.